So what's a training set? Well, a training set is a set of all of our inputs, like pictures of people, paired with a label, which is the correct output. So in this case, yes, this person is credit worthy. Versus another example.
You can tell I'm credit worthy based on my curly hair.
Purely on the hair. Versus someone who has no curly hair and therefore is obviously not credit worthy. And if you give bunches of examples of input and output pairs, that's a training set. And that's what's going to be the basis for you figuring out what is the correct concept or function.
I see. So instead of just telling me what tall means, you're going to give me lots of examples of this is tall, this is not tall, this is tall, this is tall, this is tall, this is not tall. And that's the way that you're explaining what the target concept is.
Right. So if you want to think about this in the real world, it's as if we're walking down the street and I'm pointing out cars to you and non-cars to you rather than trying to give you a dictionary that defines exactly what a car is. And that is fundamentally inductive learning, as we talked about before. Lots and lots of examples, lots of labels. Now I have to generalize beyond that. So last two things that we talk about, last two terms I want to introduce are candidate and testing set. So what's a candidate? Well, a candidate is just simply a concept that you think might be the target concept. So, for example, I might have, right now, you already did this, where you said, oh, okay, I see. Clearly, I'm credit worthy because I have curly hair. So you've effectively asserted a particular function that looks for curly hair and says if there's curly hair there, the person's credit worthy, which is certainly how I think about it. And people who are not curly hair, who do not have curly hair, are in fact not credit worthy. So that's your target concept. And so then the question is, given that you have a bunch of examples and you have a particular candidate or a candidate concept, how do you know whether you're right or wrong? How do you know whether it's a good candidate or not? And that's where the testing set comes in. So a testing set looks just like a training set. So here, our training set will have pictures and whether someone turns out to be credit worthy or not. And I will take your candidate concept and I will determine whether it does a good job or not by looking at the testing set. So in this case, because you decided curly hair matters, I've given you two examples from a training set, both of which have curly hair, but only one of which is deemed credit worthy, which means your target concept is probably not right.
So to do that test, I guess you can go through all the pictures in the testing set, apply the candidate concept to see whether it says true or false, and then compare that to what the testing set actually says the answer is.
Right, and that'll give you an error. So by the way, the true target concept is whether you smile or not.
Oh, that does make somebody credit worthy.
It does in my world, or at least I wish it did in my world. Okay, so by the way, an important point is that the training set and the testing set should not be the same. If you learn from your training set and I test you only on your training set, then that's considered cheating in the machine learning world, because then you haven't really shown the ability to generalize. So typically we want the training set to include lots of examples that you don't the testing set, to include lots of examples that you don't see in your training set. And that is proof that you're able to generalize.
I see. So that makes intuitive sense, right? So like if you're a teacher and you're telling me, you give me a bunch of facts and then you test me exactly that bunch of facts, I don't have to have understood them. I just can regurgitate them back. If you really want to see if I got the right concept, you have to see whether or not I can apply that concept in new examples.
Yes, which is exactly why our final exams are written the way that they're written. Because you can argue that I've learned something by doing memorization, but the truth is you haven't. You just memorized. Here, you have to do generalization. As you remember from our last discussion, generalization is the whole point of machine learning.